Hello, welcome to another lovely colorful algebra video. Today I'm going to talk about factoring polynomials. Okay, what is factoring polynomial? Actually, it's the reverse of multiplication. So how can we reverse multiplication? Let's say we have a polynomial like in this example 4x cubed plus 6x squared plus 4x. So how can I factor it? So I should first find common greatest common factor, which is first start with numbers. So my numbers are 4, 6, 4. What is the greatest common factor for them? 2. How about variables? For my variables, x cubed, x squared, x. So greatest common factor is x. Okay. So when I write it, 2x inside the parentheses, I have left 2 square from the 4x cube plus 3x from 6x square plus 2. Yes, so this is my greatest common factor. Greatest common factor, GCF. Okay, so we factored a polynomial. So let's make another example. So in this example, I have 8 and 8. So their greatest common factor is 8. How about for variables? So I have a to the 4, a to the a square. So greatest common factor is a square for this variables. So my greatest common factor is 8 square. Inside the parentheses, I have only x squared for 8, a to the 4 plus 1 for 8a square. Okay. Similarly, this is my GCF. Okay. Let's make another example. So 12x cubed plus 20x squared minus 12x. So all the numbers here, their greatest common factor is 4. How about for variables? I have only x. So 4x outside of the parentheses. And inside of the parentheses, I have 3x squared plus 5x minus 3. So in this example, this is my GCF. Okay. One more example. So in this example, there are more than 3 terms. So I'm thinking like we can make group factoring. So in this group, greatest common factor is x squared. And here, since we don't have any x with 6, we are looking for just numbers. For the numbers, let me use another color. So because I'm doing different things here. So this is greatest common factor for numbers. So how can I write it down? First part of my group, I have x squared outside of the parentheses. And inside I have left x plus 2. And plus the second part of the polynomial, the second group, I have 3 also outside of the parenthesis, and x plus excuse me, x plus 2. Okay, so something same, x plus 2, greatest common factor here. So I'm writing x plus 2 outside of the parenthesis, and again, this x squared and plus 3. Okay, so if I have more than 3 variables, I can make group and then factoring by groups. Okay, so until now we were using normal polynomials. Now we will learn something like in spatial pattern, like ax squared plus bx plus c. When ax square, a is 1. So let's see when a is 1. Like this example, our a is 1. 1x squared plus 3x plus 2. So how can I factor out this? So when we are factoring out, so these are my factors for 1, 2, and these are my factor for x squared. So this 2 and 1, when multiply them, I will get 2. But when I add them, I will get 3. Okay. So I'm going to write x plus 2 and x plus 1. From where I'm using this x and this 2 and this x and this 1. Okay. So done. Okay, let's do another example. So in this example, I can factor out 14. 14 is factors 2 and -7. Since we have 1 in x squares, we will factor out x squared as a x and x. Okay, so when I multiply this 2 and 7, I will get 14, -14. But when I add them, I will get -5. So 2 plus -7 gives me 5. Okay. And then when I'm writing them, I will use x plus 2 in here and x minus 7 in here. Okay. So we said if a is equal to 1, we will do something. But now we have situation like ax square plus b x plus c. Now a is not 1. So in this example, we will see a is not 1. A is 2 here. So how can I factor it? So I'm factoring 12 and 3 and 4. So here, since I have 2, one of my x's has to be 2x. Okay. And then when I multiply them, I should get 11x, like 2x and 4 plus 3x should give me 11x, which is correct. 8x plus 3x equal 11x. So I can write my factors. So 2x plus 3 and x plus 4. Okay, so this, you can say these are inner product from here, and these are outer product. This is outer. Okay, so let's see another example. So in here I have x and x, but one of them is 2x, and here I have 4 and 6. So when I multiply these numbers, I should get 16x. So this and this 2x multiplied by 6 plus 4x equal 12x plus 4x, which is equal 16x in the middle. So I can write it this 2x plus 4 and x plus 6. Okay, yeah, like you can check it. Multiply two of them. 2x squared plus 12x, and here plus 4x plus 24, which is equal to x squared plus 16x plus 24. Check. Okay, so we have some spatial patterns for factoring. So it's like if we have variable a and b, a square minus b square equals a plus b multiplied by a minus b. So let's do in examples, like these are examples. If I have variable x and y, how can I write it? So I should write it x minus y, x plus y. Okay, or let me write it exactly same order with the formula. X plus y, x minus y, same thing. Okay, how about this example? So here I have 2x, and 3y, 3y. So I will write 2x minus or plus 3y multiplied by 2x minus 3y. Okay, this is spatial pattern. I mean, this like formula, you have to memorize it. So we say this is difference of squares. How about perfect square? So if I have variables a and b, if I add them and get square of them, I can also write it like a square plus 2ab plus b square. Let's say as an example, I have 2x plus y, and I will get square of them. I can write it like, let me use another color. So I will use 2x square because this is my first term. This is my second term. I will think like this is a and this is b. Okay, and then plus 2. In formula it says 2ab. So my a is 2x and my b is y, plus it says b square. So what is my b? My b is y square. Okay, and then when I simplify this, when I get this square, I will get 4x square plus in here 4xy plus y square. Okay, let's say same example I have here. Okay, let's say same example. I will do like that. This one. If there's minus between them, like 2x minus y square. Only difference is the first term. You can see in the formula. So we can write this exactly same for x squared minus 4xy plus y squared. Only difference is for sign of the second term. Sign of the second term here. Okay, and we have one more spatial formula, and its name sum and difference of two cubes. So if I have variable a and b again, and a cube and b cube, so I can write it like, I can factor it like a plus b multiply a square minus ab plus b cube b square. And similarly, if there the sign is here negative, so we are looking for this 3 sign. Okay, if the sign is positive, a cube plus b cube, so we will use same sign, but here opposite, and here always positive. And how about here? Again, the first one will be same, and second one opposite, and here always positive. Always positive. Okay, let's see in an example again. So if we have 27x cubed minus 8y cubed, so since it's minus, we will use this formula here. And so I can write 27x cubed and as 3x. So it's 3x x's cube actually. So here it is 2y's cube. So I will use 2x, 3x and 2y. Okay, so I'm writing my formula from up. So 3x minus 2y, right? Because my a is this one. This is my a, let's say. This is my b. So my formula says a minus b. Let me write formula on the top so I can understand. Plus b squared. Okay, so what is my a from this example? 3x. So I will square 3x plus a and b. So my a is 3x again, and my b is 2y plus b squared, which means 2y squared. Okay, so when I simplify this again, 3x minus 2y, 3x square is 9x squared plus 3x and 2y, which is 6xy, plus 2y squared is 4y squared. Yes, I think it's correct. Yeah, so we learn spatial formula for the factoring formula polynomials, and that's it for today. Thanks for watching.